So I've switched microphones. Y'all let me know if it's still making that noise that it's making whenever I speak. Anyways, which that actually might be me. First thing off here, we're doing the factored form of a quadratic function. So this particular section is about factoring, which is a skill you're supposed to already know how to do. I don't know. We'll find out. The I can statement is I can find the zeros of quadratic functions. The vocabulary here is zero product property. I wish I had a clip up from a movie I saw. What is it? I'm too darn tired to think about the name of the movie. But anyways, the zero product property says if the product of, and we'll just use A and B, of A times B is equal to 0, then either A equals 0 or B equals 0, because one of them has to be a 0, because anything times 0 is 0. So one or both are zeros. All right, what is the zero of a function? Well, it's actually called lots of things. Zero of a function is the value of x that creates a value of 0 for y. The words x-intercept and roots are synonyms for zeros. That means they mean the same thing, essentially. And of course, I've already defined the zero product property, but there it is again with an example. So if the product of two or more things is 0, then one or both or all must be 0. And here we have an example. If 2 times x is 0, then x must be a 0, right? Here's how we commonly use it. Usually we factor something and we create a product of two binomials. And since we know the zero product property, we state that either 2x plus 1 is a 0 or 3x minus 4 is 0 based on this one. And I've got a lot of kids who can't do two-step equations, and I wish I knew what to do for y'all, but if I'm looking at 2x plus 1 equals 0, I'm going to subtract 1 from both sides, right? And then I'm just going to divide by 2. So x is simply negative 1/2. If I'm looking at 3x minus 4 is 0, well, then I'm going to add 4 to both sides. Then I'm just going to divide by 3. So x would be 4 over 3. I think for some it's that fraction that just terrifies you to death. I really do. I think you're scared of fractions. All right, so here's our first one up, factoring. And hopefully by now, the vast majority of you can factor simple things. I'm not going to go through a recap of Algebra 1 level factoring. This one's not too hard, but factoring 101, if you look at SpongeBob there, he says it's the rainbow method. I do think that lots of different colored pencils would probably help a lot of young females factor because you'd be making it pretty. I do. But I'll show you what I mean by the rainbow method. Now, the first terms, these guys have to create 2x squared. And the only way I know how to do that is to take a 2x and an x. The last two places, their product has to create a negative 3. And order is a big deal. Order is a huge deal. Let's try 1 and 3 and think about what happens, okay? So 3 times 2, because I swore I changed colors. I was trying to make this rainbowish for you. 3 times 2x is 6x. And in the middle, 1 times x is x. Now my goal is to add to that negative 5. It's about how everything links together, all right? So the way I do that is I have a negative 6x. And the way I create that negative 6x is that's a negative 3. Now, if that one's negative, this one has to be positive because a positive times a negative is a negative. We had a negative 3 to begin with. And there you go. She's factored. It did not say solve for x. It just said factored. A little note down here says all trinomials, which means you have 3 things, will factor. Very few actually factor with nice numbers. Everything factors, I promise you. If it won't factor with nice numbers, we either do a technique called completing the square or we use the quadratic formula. I'm just a little curious if you remember the quadratic formula. I'm going to sing it for you. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Nobody ever sang you the quadratic formula? You just found out which math teacher really loves you. That'd be me. All right, moving forward, factor the expression. So we have 2 more. These are triads, but obviously you're just taking notes. But, go ahead and hit pause and give it a shot. See if you can factor it. All right, so let's, if you've unpaused by now, let's look at x squared minus 9. it might help to think of this as x squared plus no x minus 9. It might. It might. It's actually what we call a special pattern, a difference of two squares. But even though this is a binomial, it still ends up with a double set of parentheses because I wrote it as three things. I wrote it as a trinomial. Factors of x squared are x and x. To create a 9, I either need a 1 and a 9 or a 3 and a 3. And it's worth exploring with y'all which one's going to work and which one's not going to work, especially since I'm not in class right now. My guess is 3 out of 4 of you have already figured out that the 9 and the 1 aren't going to work, because that's going to make a 9x and an x, and the goal is no x's, right? You cannot add and subtract an x and 9x in any way to get 0. Probably going to be the 3's, because this makes 3x and this makes 3x. And I know that 3x minus 3x is no x. So one of these guys is negative and one of these guys is positive. Doesn't really matter which one, they just have to sum to be 0. And factoring is something that will click if you're willing to do a lot of practice. If you're not willing to practice, it probably will not click. That's just the way it is. All right, second example, 3x squared minus 7x plus 2. These are easy because I made a, which is 3 prime. The constant is 2. 2 is a prime number. And you know, there's only so many ways to get a 3x squared, a 3x and an x. And there's only so many ways that you can get a 2. And it happens to be like this. And again, we'll explore. Let's see what happens if the numbers are backwards, okay? Because that's part of it. We guess and we check. We just guess it and we check it, okay? So, and there's other methods too. I may or may not teach you the slide divide method. I have not made up my mind on that. Anyways, I'm going to go with my first one here. The outside would make 6x and the inside would make x. Down here on the alternate one, which I already know is wrong, that'd be 3x and that'd be 2x. Now remember, your goal is to get to that negative 7, right? That's your goal. Get to 7. 2x plus 3x is 5x. 3x minus 2x is x. It's not getting there. But I know that x and 6x will get me to a 7. And they both need to be negative because I have a negative 7. Make sure that there's not a typo. Good. I was checking here. Is a negative 1 times a negative 2 positive 2? It sure is. So you guess it and you check it. Now, I had a brain fart there, forgive me. All right, relate the factors to zeros of a function. Okay, so let's talk about the zeros of this graph. You know, what is a zero? Zero, when you're talking about in terms of a graph, the zero of a graph is the x value where you cross the x-axis. Now, I just gave you a lot of words. Almost wrote cruise 2. I gave you a lot of words for x-intercepts. That's all they are. They are the x-intercepts because the y value is 0 there. So this has the following zeros. We look at the graph. The zeros are x equals 4 and x equals 5. And you'd be alarmed at how many kids can't do that. It's an alarming number of kids who can't do that. Can't look at a graph and tell you what the x-intercepts are. It scares me, quite honestly. But anywho, now, how does this relate to the factors? Well, all right, so let's factor this thing. Factor x squared minus 9x plus 20. And again, it takes an x and an x to create the x squared. You know, you think about your factors of 20. You can have a 1 and a 20. You can have a 2 and a 10. You can have a 4 and a 5. And I see that 9 there. So I'm focused on those two because 4 plus 5 is 9, right? So I know one's going to be 4 and one's going to be 5. Now, I need to add to negative 9. So they're both negative. And I got to double check here that the product is positive. Negative 4 times negative 5 is 20. So how do these zeros relate? Well, they're related by what happens when you use zero product property. So let's go ahead and just set this thing equal to 0. By that zero product property, x minus 4 is, and I'm going to drop the parentheses. I don't need them. the first factor x minus 4 is equal to 0, or slash and x minus 5 is equal to 0. And these are one-step equations. We just add 4 to both sides, add 5 to both sides. X is 4 and x is 5. Zeros can help you create a factor. There's an algebra theorem on this. And for some of you, it'll click, so I'm going to go ahead and type it out. Some of you have outstanding memory. Some of you do not. But anyways, here's a theorem. I'm not sure if you actually call it a theorem, but the idea is if x minus c is, let me say this, if x equals c is a 0, then x minus c, I can type, is a factor. And you will have heard me say this numerous times by now, and it's usually true. And I say this 9 out of 10 times, we just change signs. Look at what happened to the signs, kids. As a 0, they were positive. As a factor, they were negative. Had the zeros been negative, the factors would have been positive. Like, that's just how it works. All right, solve a quadratic equation by factoring. Now, what we want to do is we always want to rewrite in the form ax squared plus bx plus c equals 0. What we're actually trying to do is we're trying to find the zeros of the graph, or the x-intercepts, or the roots of the graph. So our first maneuver here, if we see a trinomial with 3 things, is to set the thing equal to 0, and that's just as simple as crossing sides. So we're going to set the whole trinomial equal to 0, and then we're going to attempt to factor it. So I know, and I hope that you know, that it takes a 2x and x to create an x squared, and factors of 5, and 5, by the way, is what we call a prime number, divisible by itself and 1 only, are 1 and 5. And check out my signs. The way I set this one up, positive 5 times 2x is 10x, and negative 1 times x is negative x. And 10x minus x is 9x. I can remember several students, first time they ever had me, they just breezed through school. And they would be like, Milbrath, how are you so quick at this stuff? Well, I'm probably smarter than you. I'm joking, but, they were always amazed at how quick I was because they were always accustomed to being faster than everybody else. Well, joke's on you. I'm good at math. All right, so by ZPP, 2x minus 1 is equal to nothing. Or x plus 5 is equal to nothing. Now, when I say ZPP, I'm talking about zero product property, okay? And first one on the left here is a two-stepper. 2x is 1, divided by 2x is a half. This is a single-step equation. We just subtract 5 from both sides. Now, they do have a good study tip here. It says, check your work algebraically. And it should say numerically. I don't know why they're saying algebraically. Let's check it numerically. There's 3 big thoughts in math. There's numerical, algebraic, and graphical. Those are the big 3 things. And a numeric check is to literally take these answers and plug them back in, okay? So if you want to do an easy check, it's also a very good standardized test skill. It really is. We're just going to plug our numbers in. 2 times a 1/2 squared should equal -9 times a half plus 5. Of course, now the numerical train of thought has disappeared largely because of calculators. If we take a half and square it, we get a quarter. That's 2 times a quarter. Over here, we'd have -9 halves plus 5. 2 times a quarter would be 2 quarters, which is a half. You can think about 5 as 10 over 2. And -9 over 2 plus 10 over 2 is a half. So that answer works out because we have equality. The -5 will be easier. Twice a -5 squared should equal -9 times a -5 plus 5. Now, you should know that if you square a negative, you get a positive. So 5 squared is 25. Over here, negative times negative is 45, and plus the 5. We have a 50 on the right-hand side, and we have a 50 on the left-hand side. Equality. So yes, those were definitely the solutions. They were. Now, what are these? What are these things that I just found? Okay, what are they? Let's think about what we did. We literally set the equation equal to 0, didn't we? So we found zeros of the function. Now, do you remember what zeros are synonyms with? Maybe you do, maybe you don't. I don't know. Let's fire up old Desmos here. Maybe, maybe not. There we go. Maybe, maybe not. I stuck on this. I was in the middle of uploading something. Let's see here. That was 2x to the second. And we shifted things over. We had what? Plus 9x plus 5. Is that what it was? I don't think that was it. Minus 5. We found the x-intercepts, didn't we? That's what we found. We found the x-intercepts. We found where the graph crosses the x-axis. Now, in its original form, the way they had it presented, we found where graphs crossed paths, where they intersected. So I'm just trying to show you what's going on there. And you notice that number there, negative 550? That's what we got when we plugged in a negative 5, wasn't it? All right, down here, when I plugged in a half, maybe or maybe not you remember, I got a half back. So, be thinking about graphs too, graphical, numerical, algebraically. All right, find the zeros in quadratic function. A multi-level driving range has 3 levels. Everybody goes out there and they try to hit the guy driving the cart. Marco hits golf balls from the second level, which is 32 foot high. The height of a ball x seconds after Marco hits it is modeled by the function negative 16x squared plus 16x plus 32. I've got a little side note over here for you. If you're using feet, which this example is because you live in the United States of America, all throwing or dropping of firing equations are in the form height as a function of, that should say t, height as a function of time. I don't know why I used the letter x there. Must be having a senior moment. That should be height as a function of time is negative 16 times the time squared plus v subscript 0, the initial velocity times time, plus h subscript 0, which is the initial height. All right, anyways, what is the maximum height achieved by the ball? This is a good time to talk about it, and it's just kind of a review of the other day. Maybe you recall from 2.2. I don't know if you do or not, but from section 2.2, the max or the min happens at the vertex. And the x-coordinate of the vertex is always going to be at opposite b over 2a, using parentheses because I'm writing horizontally. So to find the maximum height, first what we're going to do is we're going to figure out the x value that makes this happen. And we're going to go back and support this with graph, okay? So, boy, that's gigantic. There we go. So first, find the x-coordinate of the vertex using opposite b over 2a. Right? That's our first step. Opposite b over 2a. Now, let's go over a, b, and c, by the way. This is a, this is b, this is c. So the x-coordinate of the vertex is going to be opposite of a positive 16, which is negative 16, over twice a negative 16. That's going to be 16 over 32, and 16 30-seconds is going to be a half. So this is saying that it takes half a second for this to happen. A half a second after hitting that golf ball, it is at its maximum height. Now, to actually find the maximum height, we're going to plug this in. Because what you're doing is you're finding the y-coordinate of the vertex. And I know some of you don't remember this, but think about this as a parabola. You hit the ball will go up, and eventually the ball will come down. And what we just found is the x-coordinate of the vertex. So we want y, right? That's what we want. We can find that by plugging it in. So the height after a half a second has passed is negative 16 times a 1/2 squared plus 16 times a half plus 32. All right, so if I take a half and square it, I get a quarter. A quarter of 16 is 4. It's negative because it was negative 16. So this is negative 4 plus a half of 16 is 8 plus 32. And it looks to me like if I add these two together, I get 4, and then I add 32, I get 36, which is kind of disappointing. But a half a second, the ball is at its maximum height of 36 feet. All right, when will the ball hit the ground? Well, we hit the ball hits the ground when the height is 0. All right, give me just a second. Let me pause something. All right, now, when the ball hits the ground when the height is 0. So we're going to take that and we're going to place it with a 0. Sorry, I had an interruption there. Will this thing factor? Factors 32 or what? 16 and 2, 8 and 4? Probably not. One thing I am going to do is I'm just going to divide both sides by a negative 16. 0 divided by anything is 0. And let's see what we have here. We have x squared minus x minus 2. So yeah, it does factor. Oh, I wasn't thinking about the 16 out front. So that's something we can always do. We can divide things out. And I probably should have written a little bit differently, but it's okay for today. The right-hand side will now factor. It takes an x and an x, and factors of 2 are 1 and 2. So I need a 1 and a 2. I need to add to negative 1, but have a product of negative 2, and negative 2 plus 1 is that. So cool. Let's go ahead and solve these things. And there's a reason, a lot of teachers, when they teach a zero product property, they say the word and. This one is a solution, and this one is a solution, but it's an or. It's an or both. Let's see, so by the ZPP, zero product property, x plus 1 is a 0, or x minus 2 is a 0. So this one would say x is negative 1, and this one would say x is 2. This is not a good answer. This says that the time is negative. It's this one. It takes 2 full seconds. Now, I want to talk about that x equals negative 1 thing here. X equals negative 1 says the time is negative 1 seconds. I've had some arguments with teachers about this. They don't believe me until I show them the actual definition of what this word means, and then they're like, oh, it is right. Don't argue with Milbrath-Math. Don't do it. This is what we call extraneous. And first off, this is nonsense, right? There's no such thing as negative time as we know as we perceive it. Our brains are not capable of such a concept. It's nonsense. So this is called an extraneous solution. Now I'm going to take some time on here, and I'm going to go ahead and I'm going to graph the original equation. I'm going to pull up Desmos. Desmos is just much easier to see things. And we'll talk about why it doesn't make any sense. That was negative 16x to the second plus 16x. He was not hitting that ball hard, plus 32. So remember that this dude was 32 feet in the air, right? I'm assuming a dude. Probably it could have been a woman. Hitting things is always a good way to relieve stress. The way we play sports. But anyways, the ball goes up for a while and then it goes down. The extraneous solution here is just because of what the graph of the equation would look like. And there's that negative 1 second. But anyways, the real solution is what happens when you think about going forward. And it's right here at 2 seconds. You found the x-intercepts of the graph. You have to interpret which one makes sense. And that was 2 seconds of time. Anywho, moving forward, determine positive or negative intervals. So let's go over what a positive interval is. Positive interval is where graph lies above the x-axis. That's all it is. It's where the graph lies above the x-axis. So we are supposed to graph this thing. That's the fun part. Okie dokie. We're going to do this in a couple of steps. We're going to factor to find the x-intercepts. Now, we've already had this lesson. This was 2.2. This one will factor as x times x is x squared. Factors of -3 are going to be -3 and +1 because -3 plus 1 is -2. Now we're going to use the ZPP. X plus 1 is a 0 or x minus 3 is a 0. This tells me that x is -1 or x is 3. Now, I know that writing out ordered pairs confuses kids, but there's an ordered pair at -1, 0, and there's an ordered pair at 3, 0. All right. Do you remember how to find the vertex? Because that's the most important thing on a graph. The vertex actually lies halfway between these 2 points. It's going to happen when x is 1. Now, if you can't remember that idea about being halfway between the points, you can always fall back on opposite b over 2a, which is actually really good practice anyways. A, B, C. B is -2, so opposite of a -2 is a +2. A is the understood one, and by gosh, we get 1. Now, if we have the x-coordinate of the vertex, we can find the y-coordinate of the vertex by doing what? By doing what? We can plug it in. The y-coordinate of the vertex happens when you take that 1 and you plug it into the original equation. That's going to turn 1. This is going to make -5. It's -4. So 1, -4 is the y-coordinate of our vertex. Something else that might be worth doing is the y-intercept. It's something that's so easy to do. You just let x equal 0. And this equation is in standard form, so it's always going to be the number at the end. But anyways, it'd be a 0 squared minus twice a 0, and then minus a 3, and it's just -3. And this lets you get a better picture. Another thing worth talking about here is the axis of symmetry, the AOS, and it's at x equals 1. And the reason we do that is because it makes it more obvious. If you want a fifth point for a super duper accurate drawing, it'd be right there. Because we have something 1 to the left, we also have something 1 to the right. And here's our parabola. Remember, parabolas have some curvature. Now, I did a whole lot of work, and I can finally go back to the original question. What intervals a function is positive? It's positive if it's above the x-axis. All right, so we'll write out our answer in a couple of different ways here. It's really up to you how you do it, but you need to understand them both. We'll start with the left-hand side because that's how we read. If you're a fan of inequalities, this is true for all values less than or equal to -1. And this path is true for all values of x such that x is greater, and I don't need equality, sorry, such that x is greater than 3. So if we're a set builder kid, all values of x such that x is less than -1 and x is greater than 3. If we're an interval kid, which I hope most of you are, this thing runs left forever to -infinity, all the way to -1. It's true. Unioned with the other side, 3 to infinity, and beyond, obviously. All right, we're getting there. On this one, we're supposed to figure out where she's negative. So we're going to go through a lot of the same stuff. The big note on here is what the word negative means. It means below the x-axis. A negative interval is the values of x for which a graph is below the x-axis. I'll pause real quick. I'll be right back. So, back at it. We're going to do some factoring here. To make a 21, I'm pretty sure you need a 7 and a 3. Minus 7 plus 3, because negative 7 plus 3 is negative 4. If I'm going too fast for you, I know you can slow the speed down. I can talk super slow. You can do that. So let's talk about by ZPP, zero product property. X minus 7 is nothing, or x plus 3 is nothing. Easy problems today. This would mean that x is 7 or x equals negative 3. And again, these are your x-intercepts. You have an x-intercept at 7, 0 and negative 3, 0. So 7, 0 is right there. Negative 3, 0 is there. The vertex is always a big deal. Your x-coordinate of your vertex, it's going to be halfway in between, by the way. 7 plus a negative 3 is 4. Half of 4 is 2. It's going to be at 2. And if you can't remember that idea, what I'm doing here, thinking about symmetry in the middles and averages, you can just do opposite b over twice a. So opposite of a negative 4 is a 4. Twice a, remember a is 1. 2 times 1. And by golly, you get 2, don't you? The y-coordinate of the vertex probably will not fit on this graph because the y-intercept, this, by the way, is the y-intercept. It's at negative 21. But let's go ahead and find it anyways. The y-vertex is going to be the result of plugging in a 2. And it's going to be off the grid. I mean, that's 4 minus 8 minus 21. So that's 4 minus 29, right? Which I think is negative 25. But the lineup process is there. I'm going to draw in the axis of symmetry. I'm a big fan of that. It's at x equals 2. And your vertex is somewhere down here at 2, negative 25. It's not a big deal about the vertex either. When you're in pre-calc, a lot of times for our problems, we don't even talk about the vertex. Just depends on the context of the problem. But you guys are new to this, so we got to talk about everything. Everything's got to be talked about. Anyways, negativity on this one. That means below the x-axis. It happens from here to here. And it's about the values of x that make that part of the graph drawn, that give us that output. And our left boundary number here is negative 3, and our right boundary is 7. So if we like our set builder notation, all values of x, such that x is literally stuck between negative 3 and 7. If we like interval notation, it's simpler to write. It's negative 3 comma 7. Pick your poison. Red pill, blue pill. Don't care. All right. What do we got left? 2 to go. I've really kind of drawn this one out. This is such an important lesson, so I'm trying to go into a high level of detail on it. Write an equation of a parabola with x-intercepts at negative 2, 0 and negative 1, 0, which pass through the point negative 3 comma 20. So here's the idea. I call it general intercept form of a polynomial, but it's just general intercept form. Guess what letter of the alphabet it starts with? A. Who would have thunk, right? It's A times x minus p times x minus q, where p and q are zeros of the function. Instead of zeros, you might think x-intercepts, right? Now, I'd say 25% of you wouldn't know by looking at it. But if you look at these 2 points here, because y equals 0, x equals negative 2, and negative 1 are zeros or x-intercepts or roots of the function. So one of these represents p and the other one represents q. And then we just throw stuff in. Okay, we just feed a form. So let's feed the form. We're going to leave this as x right now. We're going to take away a -2, and then we're going to take away a -1. And taking away a negative has always been positive. And there's our form thus far. And, you still got to find a, right? You need to find a. Well, that's what the other point's for. The other point is going to give you an x and a y. And you've had some practice with this on vertex form of plugging numbers in, so it's not a new skill, at least in Algebra 2. And so let's go at it. And oh, by the way, you see this little note down here? If x equals -2 is an x-intercept, then x plus 2 is the factor, not x minus 2. Man, I bet 40% of students do this. It is such a common error. Boy, it's common. Anywho, back to my problem. I'm going to plug in some numbers. Everywhere I see a y, I'm going to be a 20. And everywhere I see an x, I'm going to be a -3. And I know, we're doing lots of little things here, and that bothers kids. There's too many steps. What are you going to do in the real world? That's what I want to know. I'm going to do a little math here. -3 plus 2 is -1. -3 plus 1 is -2. And I used to not show all this math because kids could comprehend it. Something's changed. A negative times a negative is a positive, and we divide out that 2, and we get an a value of 10. Now, when you write an equation, equations are written in terms of y's and x's, or maybe a function of x is equal to. But we have to plug that back in. We get y equals 10 times x plus 2 times x plus 1. Now, we're going to do a little extra here. We're going to put it in standard form. If you don't know what standard form is, here she is, ax squared plus bx plus c. And we're going to do that by working with that. And for some odd reason, I feel like doing vertical multiplication. I do. I like vertical multiplication. I really do. I don't know why. It just reminds me of when I was a little kid and I was still a happy person. I'm actually a very happy person. I'm just joking. 1 times 2 is 2. 1 times x is x. And by the way, that 2 was positive. Shift over. I'm just going to put the 0 there as a placeholder. X times 2 is 2x. And that 2x is positive. X times x is x squared. And then we just add down. X squared plus 3x plus 2. I had 2 or 3 kids that thus far have switched over to vertical multiplication. I've got 2 or 3 thus far that have switched over to the box method. That's why it was taught. It was taught for those who kind of stink at foiling. And done this a long time. Probably 20% of any class I've ever had struggled with doing stuff like that. And I mean, they struggled. The struggle was real. So anyways, there's still a 10 out in front of it. And I'm just going to have to hit that with the distributive property, right? Or I could, if I wanted to, I could go over here and I could do the old multiplication algorithm. 2 times 10 is 20. 3x times 10 is 30x. 10 times x squared is going to be 10x squared. It always works. Like if you remember 3rd and 4th grade and you were good at vertical multiplication, you might want to just adopt it. Anyways, we got 10x squared plus 30x plus 20. Could you do this with the box method? Yes, you could. I'm thinking of, I'm just going to holler his name out. I don't think he'll mind. Eben loves the box method. He does. He lives for it. You could put 10x squared plus 30x plus 2 up top and a 10 up here. It's more of a rectangle this way, not a square. I'm sorry, that should be a single x squared plus 3x plus 2. I was somewhere else. And then 10 times x squared, obviously 10x squared, 10 times 3x is 30x. Some people just need a visual organization method, and that's what the box method is. So it's still there. All right, the last one, and then you don't have to listen to me anymore. I know this is a long one, I apologize. Write the equation of the parabola shown in general intercept form. So let's start there. General intercept form is y equals a times x minus p times x minus q. We'll let the first one on the left be p, the second one be q. So y equals a times x, take away a negative 2, plus 2, take away 4, x minus 4. And we need to get a, so we're going to take this guy that gives us an x and y, and we're going to plug it in. 6 equals a times 0 plus 2, which is 2, times 0 minus 4, which is negative 4. Moving forward, 6 equals negative 8a, because 2 times the negative 4 is negative 8. Divide out our negative 8, and we'll get that a is negative 3/4. Plug that back in right there, and here is your equation. Negative 3/4 of x plus 2 times x minus 4. Standard form is where we do a little math with this. And I'm not gonna, you just heard a bell ring, so I'm not gonna do vertical multiplication. You're gonna have your negative 3/4. X times x is x squared. X times negative 4 is negative 4x. 2 times x is plus 2x. Negative 4x plus 2x is minus 2x. And 2 times negative 4 is negative 8. And I'm going to distribute the negative 3/4. That'd be negative 3/4 of x squared. A negative times a negative is a positive. 3 times 2 is 6. 6 over 4 is 2. Sorry, 6 over 4 is 3/2. Negative times negative is positive. 3 times 8 is what? 24, right? 24 divided by 4 is 6. Vertex form. Vertex form. All right, so let's do this. This would be where the axis of symmetry is at, and that's x equals 1. And it happens to be the ordered pair here. The vertex happens at 1 something, okay? To find the y-coordinate of the vertex, I'm going to take that 1 and I'm going to plug it in. Doesn't really matter which one you plug it in. Pick any equation you like. I'm actually going to use this guy right here. It's negative 3/4 of a 1 squared minus twice a 1 minus an 8. Let's see here. Inside I have 1 minus 2, which is negative 1. It's negative 3/4 of 9. Negative 9 at that. So that's going to be negative 3 times negative 9, 27 over 4. So let's talk about what I just talked about. The x-coordinate of the vertex was 1. The y-coordinate of the vertex was 27/4. This is h. This is k. The vertex form is y equals a times x minus h quantity squared plus k. P.S. That's a. So y is, I could have swore I've been changing colors here, negative 3/4 x minus 1 quantity squared plus k, which is 27/4. And yeah, that video was long, and it is such a big deal that you get this particular section down. And it's such a building block of the rest of this course. And only a handful of you will realize that as we progress, but it is a building block for this course. Very important lesson. Sorry it was so long. I just took my sweet time, wanted to explain as best I could. It took up my whole planning period, by the way.